Okay, example 1. We want to verify that the quadratic curve has a maximum turning point at 2, 7. So verify means that first of all, show that the turning point is 2, 7, and then show that it's a maximum. Now, the question is about turning points. Remember, at a turning point, the actual gradient is 0. So your mind should be thinking about gradients. And because we're thinking about gradients, we need to calculate or get the general gradient first. So we've got our curve, it's ready to differentiate, so let's get the general gradient at any point, which we know as dy by dx. So we're going to differentiate the curve, so dy by dx. So differentiate a number, it disappears. Differentiate 4x, we're just left with a coefficient of x. Differentiate minus x squared, that's going to give us minus 2x. So that's the general gradient at any point on the curve. Now, we want to get the x coordinate of the turning point. So, the x coordinate of the turning point occurs when we set the general gradient equal to the actual gradient, which is 0 at the turning point. So we start off now to get the x coordinate of the turning point, and that is always the solution of dy by dx equal to 0. That's what happens at the turning point. The general gradient is equal to the actual gradient, which is 0. Okay, so sub in what dy by dx is, 4 minus 2x, and that's equal to 0. So we've got a nice little equation with x. We're going to solve it to get the x coordinate of the turning point. So we're going to get 4 equals 2x, and then divide both sides by coefficient. Then we're going to get x is equal to 2. So good news, there's the x coordinate of the turning point, and it makes sense because it asked us to verify that the turning point had an x coordinate of 2. So we're expecting an answer of 2. We're now expecting the y coordinate to be 7. So once you've worked out the x coordinate of your turning point, we now get the y coordinate. Because the turning point lies on the curve, you sub the x coordinate of the turning point into the curve. So go back to the curve and replace everywhere you see x with 2. So we're going to get y equals 3 plus 4, and then replace x with 2 in brackets, and then subtract, and then 2 all squared. Put 2 in brackets and we're squaring it. So to get the y coordinate of the turning point, we sub in the x coordinate of the turning point into the curve. Okay, so let's tidy it up. We've got 3 plus 8 minus 4. And that's going to give us 7. And again, makes perfect sense, because if we go back to the question, we had to show the turning point was 2, 7. So we've just done that. So turning point is 2, 7 as required. Okay. We know that the turning point is 2, 7, but we need to get its nature. In other words, is it a maximum turning point, is it a minimum turning point, or is it a point of inflection? So next thing we look for is the nature. So nature of turning point, and that means we have to get the second derivative, d2y by dx squared. So, how do we get the second derivative? Well, you go back to the first derivative, dy by dx, and you differentiate again. So if we differentiate again, the 4 disappears, and we're just going to be left with a coefficient of x. We're just going to be left with minus 2. So the second derivative, d2y by dx squared, is equal to minus 2. Now, because we were working with a quadratic curve, when you get the second derivative, it'll always be just a numerical value. However, when you look at cubic curves, the second derivative will not be just a numerical value, it will actually still have x in it. And when the second derivative still has x in it, what you do is you sub the x coordinate of the turning point into it to work out what the second derivative is. But we can't do that here. We can't sub the x coordinate into the second derivative because there's no x in its expression. So the second derivative is negative here. In other words, it's less than 0. And as we were saying earlier, if the second derivative is less than 0, that tells you the turning point is a maximum. As required. Now, we've answered the question in full. We have proven what the turning point is, or verified it, and we've verified also that it's a maximum. Now, here's the beauty about this question. You would have had an idea of the nature of the turning point before you even proceeded with the question, because if we go back to the question, it's a quadratic curve, and the coefficient of x squared is negative, so that means it's an unhappy shape. So, you know, it should tally up with what's in your head here. What's in your head is, it's a quadratic, it's an unhappy shape, so it's going to be like that, and therefore at some point in the curve, y is going to have its maximum value. So that fits in with the maximum turning point. So also, coefficient of x squared is negative. So the two things fit together. Okay, and that's example 1.